Okay, Assalamualaikum and hi everyone. We continue our discussion. So now it's about a degree of dissociation, or the symbol here is alpha. Alright, so first of all, okay, so we take a look at the definition. So it can be defined that degree of dissociation is fraction to which molecule dissociate, or in the other word, decompose into smaller molecules or atoms, which means from bigger molecule into smaller molecule, or bigger atom into smaller atoms. Right, so we have formula here. Right, so if the question asks about degree, so it's meaning that you have to calculate in form of fraction or ratio. Ratio. Okay, how to calculate the changes in concentration of reactant, that is referred to X, over initial concentration of reactants. Okay, so this is in terms of ratio or fraction. Okay, for degree of dissociation. If question asks percentage dissociation, right, so just very simple, it's just the same formula, change in concentration of X, which refer to X, over the initial concentration, times 100%. Okay, right, so we take a look at this example here. Okay, so given to you the 0.024 mole sample of N2O4 gas is allowed to come to equilibrium with NO2 gas in 0.372 liter flask. Given to you the value of Kc, and question asks you to find out the degree of dissociation. Right. Okay. Right. So refer back the equation. So the formula alpha is equals to concentration changes over initial concentration. So therefore we have to calculate the initial concentration here, and to find out the changes, so we have to solve by using ice table. Okay, so for the ice table, so first of all, say in the question is not giving the initial concentration, so we have to calculate the initial concentration. Mole, for the N2O4 initial over volume. So the initial concentration of N2O4 is 0.0645 molar. Okay, as for the product, 0 because not formed yet. Alright, next for the change in concentration, refer to the coefficient. So coefficient for N2O4 is 1, so it will decrease negative X. Okay, as for the products, the coefficient here is 2, so it will increase by positive 2X. Okay, so at equilibrium, so remember concentration initial, for the reactant, minus X. Okay, as for the product, 0 plus 2X equals to 2X. Right, so next write the Kc expression and substitute the values. Okay, so the values here for NO2, so refer to the equilibrium, at equilibrium, so which refer to 2X here. Okay, substitute 2X squared. As for the concentration for N2O4, say 0.0645 minus X, and is equal to the value of Kc. Alright, next you have to solve this calculation until you get quadratic equation. So this is B, and this is C. Okay, by using calculator, find out two values of X1 and X2. Alright, so for this one, we have one positive value, X1 is positive, X2 is negative. So which one should we choose? So same thing goes from the previous calculation. We will prefer the positive value. But why? So refer back to the ice table. So for at equilibrium, the concentration for NO2, for example, so here is 2X. Okay, which means NO2 concentration is referred to 2x. So the x value here should be positive in order to get positive value of concentration. So that's why we choose x1. So right, accepted. As for the x2, since it is negative, so not accepted. Right, not accepted. Okay, next. Okay. Right, so substitute into the formula of degree of dissociation. So where x here is referred to the x1, 0.00806. Okay. Okay. This one, x1. Substitute. Okay, as for the initial concentration is 0.0645 molar. So we get the degree of dissociation is 0.125. If the question asks percentage, you just times 100%. Okay? Alright.